With that, we then go on to writing the same sort of contribution from the forcing terms. Okay. So for the contributions from the forcing terms, we have again C2, C3 up to CNEL, CNEL plus 1. Okay. Now, looking back again at that expression for the finite dimensional weak form where we've explicitly written out the contributions from each element, what we see is the following. So once again, let's assume that FA F and A are the same for every element, right? They're uniform over every element, and in fact, they're the same for every element. That allows us to pull FA over 2 out as a common factor, leaving us then with the task of just filling out this vector. Okay. Now, the contribution from the very first element, okay, if you go back and look at your notes, would have been H1. Okay. For element 2, right, we recognize that element 2 has contributions coming from the C2 and C3 degrees of freedom. Okay, right? And then if you go back and look at the expression that we have for the forcing function on the right hand side, you will see that the contributions here are of the following form. We have H1 plus H2, okay? H2 coming from element 2, okay? Element 2, however, also has a contribution corresponding to C3. So that appears here as H2. And then we go on to element 3. Element 3 has contributions from C3 and C4, which is the degree of freedom sitting next to C3. Okay? Right? The contribution from C3, since we're now talking of element 3, would be H3. Okay? The contribution corresponding to C4, since we're still talking of element 3, would be H3. Okay? The process continues until we reach the last two entries in this forcing function. Okay? The last but one entry will have a contribution from corresponding to CNEL, but that would come from the last but one element. Okay? And so that contribution would be HNEL minus 1. Okay? That entry would also have a contribution from the very last element, HNEL. Okay? And the very last entry of the forcing function of this vector that we're trying to develop would have a contribution only from the very last element. And that would be corresponding to that degree of freedom. Okay? That would also be HNEL. Okay? This, once again, using this notion of the assembly operation of finite elements, is the assembly over E equals 1 to NEL, okay, of C1E, C2E, FA, HE over 2, FA, HE over 2, right? This is the contribution that we've assembled. And again, that's just an abstract way of writing this operation. The detail of doing that operation involves the sort of mappings that we've just used here to write out these global vectors from the local ones and the sum over the elements. All right. Now there's one more contribution. If you go back and look at our finite element at our finite dimensional weak form, you will observe that we have a term that comes from the traction condition. Okay, It's the one that we may have actually had on the previous slide as well. Right. On the previous slide, it is this contribution. Right? That comes from the weighting function degree of freedom C2 NEL. Okay? Right? And we know how that maps on to the global numbering system for weighting function degrees of freedom. Right? This contribution then will appear in this position, right? The very last position here. Okay? It will be corresponding to C NEL plus 1, right? Because C NEL plus 1 is the same as C2 for element NEL. Okay? So that contribution here is, well, we can't quite write it directly into this vector, so let us then also write it as follows, right? So we include here all the C contributions, right? The reason we couldn't write in the vector above is because we have this constant factor multiplying that vector. Okay? So instead, we just observe that this thing can be written with a bunch of zeros all the way up to the very last entry. And for that very last entry, we just have T times A. T being the traction, A being the area. And this is just our very simple-minded way of writing C2 NEL times T times A. Okay? All right. What I'm going to do now is pull all these terms together, right? And write them out in one single expression. C2, C3, CNEL, CNEL plus 1. Okay? This is multiplying EA. And again, for okay, I was going to try and make some things even easier for us using by assuming that all the elements had the same length, but let's not do that right now. Okay, so the expressions we have here are minus 1 over H1. So what I'm doing here is putting together all the stiffness matrix terms. Okay, here I have 1 over H1 plus 1 over H2. I have minus 1 over H2 here. Here I have, I have minus 1 over H2. Here I have 1 over H2 plus 1 over H3. I have minus 1 over H3, minus 1 over H3, 1 over H3, plus there is another term that will come here from element 4. It will be 1 over H4. Okay? That process continues, and when we finally close out this matrix, we will have here we will have here 1 over H N E L minus 1, 1 over H N E L. We will have here minus 1 over H N E L. We will have here minus 1 over H N E L, and here we will have 1 over H N E L. I recognize that what I'd written on the previous, when we actually developed this a couple of slides ago, was a little cramped. Hopefully this is a little easier to read. Okay, all of these, this matrix multiplying here our global degrees of freedom, D1, D2, all the way down to D, N, E, L, D, N, E, L plus 1. These are all the contributions coming to us from the left-hand side of our finite dimensional weak form. And they are equal to terms that came from the right-hand side from the forcing function as well as the traction. All right? And in order to get those together, let me just go back to this slide, our previous slide, and make sure I save it so I can work off it, and then I can come back to where we were. Okay, so the right-hand side then involves the same vector that we had up here. Okay, the same row vector, C2, C3, CNEL, CNEL plus 1 multiplying FA over 2 is the vector H1 plus H2, H2 plus H3, H3 plus, in the dots there will be H4, but at some point I do have to just stop writing those and use dots for extension. And down here I get HNEL minus 1 plus HNEL, and here I finally get HNEL. Okay, we have this, and then we have the final contribution coming from the traction. Again, we have C2, C3, CNEL, CNEL plus 1 multiplying the vector with zeros everywhere all the way down to TA. All right, we're done with finite element assembly. But we're not done with our final sort of tweaking of this of the equations. There is more work we need to do here, but the big task of assembly is done. We'll stop the segment here. When we return, we will come back to these matrices, to this general matrix vector expression, make some observations about it, and turn it around to the final form in which we will actually solve the problem.